All right, good morning. And today we are talking about translations, or I could say we're talking about transformations, and specifically within that, translations. So, a transformation, this is going to be a change in the position, size, shape of a figure or graph. Okay, so if we think about it, a transformer, we probably are familiar with like Bumblebee, Optimus Prime. They're cars that transform into these, or monsters that transform into these cars, and vice versa. Ours aren't maybe this exciting, but we have a shape. It transforms in some way. It moves or it looks different. It gets stretched. Some of those. So specifically today, we'll talk about a translation. Now, when a translation occurs, every point of a figure or graph is mapped the same distance in the same direction. Okay, so whether that's up, down, left, right, or some combination of those, the shape will look the same, just be moved in its location. Now, our next two words, pre-image and image, they go together. Pre-image, hopefully we know like pre-season is before the season. Preview, you watch before the movie of them, show you what it's about. Pre-existing means it was already existing. Prehistoric, lots of words. Pre, we know is before. So this is our initial set of points, and the image is our resulting set of points that we get. If we look here, it's our x and our y coordinates. Hopefully you know this is our x-axis, and this is our y-axis. To the right is positive, to the left is negative, up is positive, down is negative. So, if we look here, it says, when translating a figure in a coordinate plane, you can write the translation vector in component form. So right here, do you see how it's a vector now. It's got the points on the end, it's not just parentheses. Okay, A is going to represent the horizontal change, B would be the vertical change. So in that case, A and B, A is if it moves left or right, B is if it moves up or down, and that results in some vector here. So, on to the next one. Now we are going to start by plotting our pre-image, our initial shape. Okay, so they tell us it's a triangle of A, B, and C. Now keep in mind, negative 5, 3, that's an x and a y coordinate. So we start at the origin, right here in the middle. Negative 5, 3 means left 5, 1, 2, 3, 4, 5. 3 means up, 1, 2, 3. And that is our A, our pre-image for A. We'll do the same with B, right 4, up 2. And then C is negative 1, so left and down. Okay, then we connect our dots, and we have our triangle. So that is our initial shape. We are going to use that to find what our image will be. Now, up here, you'll notice this is x minus 3, y plus 4. So that is meaning it is going to shift left 3, up 4. So this whole shape right here is going to move to the left 3 and up 4. Now, we were writing this as a vector in component form. We would write this negative 3, 4. We have two options on how we find these points. We either take our initial points and plug them in here, or we can look at our graph and count it over. So we'll do it both ways, but if we move left 3, up 4, I can start at A and go left 1, 2, 3, up 1, 2, 3, 4. Okay, now to distinguish this from the initial point that we had, the pre-image, I'm going to put A prime with that little mark. That tells us this is the result. We'll do the same, left 1, 2, 3, up 1, 2, 3, 4, and that one will be B prime. And finally, left 1, 2, 3, up 1, 2, 3, 4. This results in C prime. We connect our dots, and hopefully you can tell it is the same shape, just shifted to the left and up. Now, if instead of on the graph, or maybe you didn't have a graph, you could also find it out by plugging these x and y values into this equation. Initially, we had an x and a y value, negative 5 and 3, and then negative 5 minus 3. So A prime results in negative 8. Meanwhile, 3, if we add that to 4, we get 7. Okay. Likewise, B prime, 4 minus 3 is 1. 2 plus 4 is 6. And finally, C prime, negative 1 minus 3 is negative 4. Negative 1 plus 4 is 3. And if you wanted to check any of these, like B prime 1, 6, we start at 0, 0, it's right 1, up 1, 2, 3, 4, 5, 6, and we're good. It matches up. So on example B, we have R, S, T, and U. Those are our 4 points. So R, we just plot 1, 2, 3, 4, up 1 or down 1. It's R. S, negative 2, 0. T, negative 1, 3. And U is negative 3, 2. Once again, connect your dots. And there we go. Now, once again, this one is moving to the right or left 3. Okay, so left 3, up 4. So give me 1 second. All right, so left 3, up 4, just like the last one. So in component form, it will be the same thing. Negative 3, 4. Okay, so we take each of these points. I don't care which order you do it, whichever one you think is easier. So R prime, if I plug that in, negative 4 minus 3 is negative 7. And negative 1 plus 4 would be 3. S prime will do the same thing. So negative 2 minus 3, negative 5. 0 plus 4 is 4. T prime, negative 1 minus 3 is negative 4. 3 plus 4 is 7. And finally, U prime, negative 3 minus 3 is negative 6. 2 plus 4 is 6. Okay, so R, S, T, and U. Or you could count them over. It's up to you. You can plot these points or count them over, whatever you think is easier. So left 3, up 1, 2, 3, 4. That is where all of our points will go. And we can connect those dots. And we are done. So there is more to the notes, but we will jump back in with this tomorrow. Now, to finish out today, I need you to go to Delta Math. There's an assignment. I want to show you specifically one type of those problems, okay? So the third type of problems, the first ones are pretty straightforward. The third type says translate a figure by vector guided, okay? This isn't hard. I just want to make sure you know what it's asking. So it says translate the figure 2 units left and 1 unit down. Now, the instructions here. Draw a vector from the origin, 2 units left and 1 unit down. So hopefully you guys know the origin is right here at 0, 0. So if I go 2 units left, 1, 2, and 1 unit down, and if I let go, and I'm done. Now it says move the tail of the vector to each vertex of the figure. The vertex, or the vertices, are the points. So I just grab this. The tail is right here. This is the head of the vector. I just grab it and drag it to that. Let go, it returns. I have to drag it to each of these in order to get my points. So it's not hard. I just wanted to make sure you knew what it meant for you to do. And it shows where the figure will end up. It will move right there. And we submit it, and we're good. It'll show you an animation, which can be handy if you're having trouble visualizing this. So hope you guys have a great day, and I will talk to you guys later. Please get the Delta Math done. If you have any questions, please reach out and let me know.